So for this section, we're going to talk about multiplying polynomials. So in the first one, we only saw adding and subtracting where you guys were putting together like your like terms. So multiplying is going to be similar to what we saw like with our quadratics when we were foiling things and you had to kind of use your distributive property more than one time. We're going to kind of see that happen again here with multiplying polynomials. The only difference is that instead of just having two quantities with two terms, you might have one that has like an x plus 5, and then the thing that you're multiplying by could have 4 or 5 terms to it. It could be a much bigger polynomial that you're dealing with there. So I just kind of want to review, if we were trying to simplify kind of what the difference is when you're just adding letters or adding variables with exponents versus multiplying them. So when I look at these 4 examples here, x squared plus x squared, since they're the same thing, they both have an x and they both have a 2, we can combine that because there's 2 of them. So I can rewrite this as 2x squared. So like that's what you would have done in section 1. If you had multiple x squareds, you could have added them to simplify them. Now number 2, I have x squared plus x to the third. They have different exponents. So I can't combine them together because one is an x squared and one is an x to the third. So I can't do anything here, so I'm just going to leave it as is. Now, multiplying changes things a little bit. When we talked about properties of exponents way at the beginning of the year, when you're multiplying letters with exponents, you have to add the exponents together. So for this one, you're taking x squared times x to the third. They have to have the same base, which is the x. So x stays the same. We have to multiply the exponents together. Add the exponents together. So 2 plus 3 is what I'm doing here. So I get x to the 5th power. So a little bit different than when I was adding them. So for number 4, we do the same thing. We're taking negative x to the third times x to the 4th. Now the negative x to the third is just going to make this whole answer negative. And we're going to add the exponents. 3 plus 4. So this should be negative x to the 7th power. So when you guys are multiplying today, you're going to see this happen where you've got a letter times a bunch of other ones in your polynomial. You have to make sure with those exponents with the same base that you add the exponents together. So if you've got an x times an x, you have to add the exponents 1 plus 1 to get x squared. It only works though if they have the same base. So if you're taking like an x times a y, you're going to leave that as just x times y. They're just going to get kind of stuck together. They're not going to become like a new letter with a new exponent. When we're multiplying polynomials, we use, like I said, that distributive property. So it's really helpful, especially as you guys are just kind of learning how to do this, to make sure that you're drawing those arrows like we've seen in the past. So like this first one, I have 4y squared times y squared plus 3. So I'm going to take this whole quantity, 4y squared times y squared, and then times 3. So when I take 4y squared times y squared, there's no number for 4 to multiply by, it's just a 1. So it's still just going to say 4. But now let's talk about the y. So y squared times y squared, you'd have to add those exponents. So what's 2 plus 2? 4. So this is going to become 4y to the 4th power. Plus, bring down that plus sign. Now we distribute the second time. So we're taking 4 times 3, which is 12. And then y squared is just going to attach, because it doesn't have anything to combine with, because 3 doesn't have a y next to it. So I don't have to change my y squared at all. It just kind of gets dragged along with the rest of the problem. So this is my answer. You can't combine those two things because the y's have different exponents. Y to the 4th and y squared are not the same thing, so we can't simplify that any further. Now, for number 2, you're taking AB times all of these quantities. So times a to the 4th, times 2a to the third b times negative 3a squared b squared and times ab to the third. So we're going to have to distribute 4 times here. Because I have ab, that's 2 separate letters here, the only time that I should be adding exponents is if I'm multiplying my a times another a or my b times another b. So some of these terms, like the first one, a to the fourth, doesn't have a b term to it. So the b that I'm multiplying by is just going to kind of follow along with that portion. When I take a times a to the fourth, though, what's that going to become? Good, a to the fifth. And then, like I said, b is just going to kind of tag along. Now, for the second one, I have ab times 2, a to the third b. So the 2 is not going to change, so I'm going to write plus 2. A times a to the third is going to become what? Good, a to the fourth. And now we have b times b. What's that going to be? Good, so b squared. Okay, you guys try to finish it out. Do those last 2. We'll see if they match mine. So ab times negative 3a squared b squared, you should have negative 3. Then a should become a to the third, and b should become b to the third. And then ab times ab to the third, so you have plus, it should become a squared b to the fourth. Okay, so make sure that you got that same thing there. All right, so those 2 are just taking like a monomial term times a polynomial. Now we're going to talk about how do we handle it if we're multiplying 2 polynomials together. When you want to multiply 2 polynomials, you use the distributive property twice, or you could use it 3 times, 4 times, however many times that you need to use it in order to make sure that you're multiplying all the terms. So these problems can get kind of messy really fast because if you're drawing arrows, there's going to be a lot of arrows for some problems. So some students in the past have used like different colors, or they draw one set of arrows, they like write out what that should be, they go and they erase and then they draw another set. Do whatever you need to do to keep track of what you have multiplied so that you don't forget something or, skip over one of the pieces. So what I'm going to do first is I've got a minus 3 times this 2 minus 5a plus a squared. The first thing that I'm going to do is take a, and I'm going to draw arrows so that I multiply it to every term in that second set. This is basically like foiling, but I don't have a nice simple rule that I can follow here because I've got 3 terms. It's not 2 terms times 2 terms where I could do first, outside, inside, last. So I have to do a little bit more work here. So the same rules like we were just doing apply. I'm going to take a times 2, which is 2a, a times negative 5a, that's going to be negative 5, and then a times a is a squared, and then a times a squared is going to become a to the third. Now I have to go in, I have to distribute a second time. So I'm taking negative 3 times 2 times negative 5a times a squared. This is why I said you're going to have a lot of arrows in some of these problems. So if it's easier for you as you're working through them to use different colors or to erase arrows after you've used them, do that if it gets too confusing. So I'm taking negative 3 times 2, which is going to be negative 6. Negative 3 times negative 5a. Negative 3 times negative 5 is going to become positive 15, and then we have a attached. And negative 3 times a squared is going to become minus 3a squared. Now, we're not quite done, because what we need to do is look at our problem here. Look at this whole polynomial and see if there's anything that we could combine. Are there any like terms that we could put together to simplify? So, first of all, I look and find like the biggest exponent, which I see an a to the third. And I don't see any other a to the thirds here. So that's the only one. So I'm just going to bring it down. And I'm going to cross it off. Now for a squareds, I see a negative 5a squared. And I see a negative 3a squared. So negative 5 and negative 3 is going to be negative 8a squared. So I'm going to cross those off. Now for 2a, I have a 2a and I have a 15a, so that's going to become 17a. And then that minus 6 is the only number, so it's going to just attach to the end there. So I cross them off as I go. That kind of helps me keep track of which ones I've combined so far. And it also lets me know what's left. Okay, so this is your final answer. All right, so I'm going to do another one with you guys, and I'm going to show you a different method other than the distributive property. And this method that I'm going to show you, it's called the box method. And I feel like it's easier to use when you have large polynomials that you're trying to multiply together. So when you've got really big pieces, it kind of helps keep it a little bit more organized, and then you don't have to worry so much about drawing a whole bunch of arrows necessarily. So like for this one, each polynomial has 3 terms. Okay, so if I was using the distributive property, which you can totally use, I'm not saying you have to use the box method, but some of you are going to like it better. You would take y squared, go to y squared minus y minus 3. Then you would do negative 7y to y squared minus y minus 3. And then you would do 5 to y squared minus y minus 3. That's 3 sets of arrows that you'd have to draw. Okay, so this box method is going to kind of avoid that. And what we do is we write out the 2 polynomials. You keep the same signs and everything. We put 1 across the top. So like y squared minus 7y plus 5. And we do the other one going up and down on the left side here. So y squared minus y minus 3. Notice that I'm keeping the sign, the minus sign, in front of the y and in front of the 3. So don't forget about those. And then I'm going to draw in the rest of this box here. So what you do to fill in the box is you take the piece from like either the top or the left column that kind of match up for that box, and you multiply them together. So for this first one up here, I'm going to take y squared times y squared. And that's going to be y to the 4th power. So this first column here is going to be y, or this first box is going to be y to the 4th power. Now you can go off to the right, or you can go down the columns if you want. You can either do the rows or the columns in either order. It doesn't matter which one you do first. If we're going across to the right here, and I'm taking y squared times negative 7y, you're going to have negative 7y to the 3rd. Then if we take y squared times 5, that's going to say 5y squared. Are you guys seeing how I'm getting those numbers? So now I'm going to go to the next one. So from this one, I'm going to take negative y times all of those pieces. It's the same idea as distributing. I'm just not doing the arrows here. I'm just putting it in a box. So negative y times y squared is going to be negative y to the 3rd. negative y times negative 7y. Watch your signs here because you're taking a negative times a negative. So that becomes positive 7, and then it's y squared. Then we have negative y times 5. So that's going to make that become negative 5y. Okay, last is to do negative 3 times y squared. So that's negative 3y squared. Negative 3 times 7y is going to be positive 21y. And then negative 3 times 5 is negative 15. So if you were using the distributive property, you should get these exact same pieces that I got. But here's the other kind of neat thing that happens with this box method. Your like terms. So remember up here, guys, when we had to combine like terms? And I went through and I underlined which ones and then I crossed them off after I combined them. Look at your box. You see the pieces I'm circling here? All of your like terms should be diagonal to each other in your box. So instead of having this really long sentence and you're having to search through to find all the y squareds, mine now are all diagonal to each other in this box. Which, if it's confusing or if you find yourself forgetting a term when you're trying to combine things, this is going to help you avoid that because they should all be in a nice diagonal row. So then what you can do, now notice like y to the 4th and the negative 15, they don't have anything to pair up with. So they're just going to be by themselves. So we're going to have y to the 4th. Now my y to the 3rds, I have a negative y to the 3rd and a negative 7 y to the 3rd. So that's going to be negative 8 y to the 3rd. So I'm just going to cross those boxes out as I go. Now my y squareds, I've got negative 3, 7, and 5. So that's going to end up being a positive 9 y squared. My y's, I have 21y and a negative 5y, so that's going to be 16 when I add those. And then last is that negative 15. So, you guys can choose whether you want to use the box method or not. When I'm doing these really big ones, I kind of like to use the box method. I think it makes it a little bit simpler and it organizes it a little bit more for me. But you can absolutely use the distributive property if you would rather do that. Now there's one more on this page and I want you guys to try it and you guys can use whichever method you'd prefer. So you can use the box method, you can use your distributive property. I'm going to give you a little bit of time to try to do it and then we'll come together and we'll figure it out together. So I would check your box with mine. Make sure you have the same numbers that I do. Watch your negative signs, okay? Because you have a -1 in there and you have a -2. So that is going to affect the signs of some of your terms here. So you just want to make sure that you're being a little careful with that. So after I have these terms here, again, my like terms are diagonal from each other. This one's a little goofy, isn't it? Oh, that's because they have different, like this one starts x to the third and this one started x squared. So they still kind of are diagonal, but they're a little off. So I'm just going to kind of circle them up there. So if I go starting at that 3x to the 5th, because that's the biggest one, that should come first. And now my x squared, 6 plus 9 is going to be 15. So that's x to the 4th. So plus 15 x to the 4th. Now my x to the thirds, I have -2 and an 18. So that's going to become positive 16 x to the third. X squareds, we have -6x squared, -3x squared. So that's -9 x squared. And then we have the -6x kind of all by itself and the +2 all by itself.